Okay, doing a little bit of review for the Chapter 9 test is on sequence and series, and also has a little bit of induction. That's what I'm starting with here. This is an induction setup, and you have to be able to know how to kind of get it set up. You don't have to go all the way to the end on the induction proofs, but at least you have to know step 1, 2, and 3. Okay? Now, one of the things, we're going to be referencing some files here that are, I'm going to call these, this is the formula sheet for the test, and I'm going to call them from the top down A, B, C, D, E, and F. So if you want to copy those down, if you're watching the video at home, these are the key formulas that you need to be able to handle arithmetic and geometric sequences and series and their sums, including infinite sums and the binomial theorem. All right. So I'm just going to slide this over for a second. Do you see the n over 2 in this formula? It's kind of a giveaway that I'm doing that second formula down there, which is what I would call B. And I'm going to prove it using math induction. All right. So if I wanted to do this, I have to label my steps. You do on the test. You do too. Step 1. What is step 1? If you just say n equals 1, you're not saying what to do with it. Prove for n equals 1 equals n equals 1. Okay, so prove for n equals 1. Then, if n equals 1, they're saying there's only one term. If there's only one term, then I can just use this part of the formula because that is a term generator, and they'll generate the last term for us. And since there's only one term here, it would be 2 times 1 minus 1 equals n, which is, how many terms are there? 1. 2 plus n is 1 again. And we'll just double check that that worked. 2 times 1 is 2, minus 1 is 1. And then here we have 0 times 2 is 0, plus the 2 makes 2. And then 1/2 times the 2. 1/2 times 2 makes 1. Yay, it worked. I proved it. Now that didn't have enough work in it. I needed to show a little bit more. I was trying to save space, but I would need to simplify down this left side, maybe one step of simplifying. You need to show work. This is really important because if you just jump right to answers, I have every right to not give you the credit for it because it's too easy to copy off somebody else's paper and not understand what you're doing at all. You got to prove to me when you know what you're doing. Yes, ma'am. Because we're trying to prove that this formula works. I know that the first term is going to be 1, okay, but does this actually generate 1 is the question. And then on the other side, when you have only one term, does this actually give you the sum of all the terms? Which it does, because 1 is equal to 1. All right, so that's step 1. Step 2 is kind of weird. If we've proven that it works for a number, now we got to prove it works for any randomly chosen term, a number of terms, like 5 terms or 7 terms. But I can't just go pick another number. All I've done is prove another number works. I have to prove it for n equals k. So it's as simple as recopy the formula with a k in it. Please do that. And then see if you know how to do the last step. See if you can set up that last step. Step 3. So step 2 is just let n equal k. And we are assuming that if we change a variable, it is an assumption. We are assuming that if we just change the variable that it will remain true. And that's kind of actually up for some debate amongst math teachers, but we agree that it's ludicrous to make people prove that if you change the variable that it's going to stay the same. Okay, so now it's 1 plus 3 plus 5 plus ... 2n minus 1. I'm leaving some room here, changing it to k, sorry. 2k minus 1. I'm leaving some room here so I can do step 3 right in with step 2. And over 2 plus n minus 1 times 2. And that's step 2. Step 3 I will do in blue. All step 2 was the same exact thing, except, oh, I'm supposed to replace everything with a K. I apologize. This N is supposed to be a K. I got so busy copying that I forgot to change. And this N right there, that's supposed to be a K also. Sorry about that. Okay, so there. I just changed it to a K. Who can do the next step? Raise your hand if you can do the next step. There's quite a few of you. What do you think, Miss W? I'm going to do it in blue here. Add. If I just add a K plus 1 to both sides, you're warm, but you're not right. Here's why. Do you get that this is what we got when it was just K? So now we need to stick the K plus 1 into this and then put that here. So now I'm sticking K plus 1 in for the K, and I'll have 2 K plus 1 minus 1. Raise your hand if you had that already. Okay. All right. Just think about this for a second. If we add another term, this term doesn't like disappear, does it? It's still there. We're just adding another term to it. What would the next term after this be? It would have to be the same exact thing except without a K, but with a K plus 1. And if I add it to the left side, like I just did, I have to add it to the right side. There we go. And this are identical. The reason is because if you add something to the left side of your equation, you have to add something to the right side of your equation. Raise your hand if you think you could replicate that. Okay, that is induction as far as you have to go. And I did show you how you could finish these. To finish it, you would have to take this, and by algebraically manipulating it, a lot of it would come down to if you can factor it, you should, and common denominators and things like that. You could algebraically manipulate it into the original statement again. Back up to the original. This original statement right here, except not with n's and not with k's, but what do you put into that one? K plus 1s. You want this to get manipulated, this guy right here, all of this side has to get manipulated down until it looks like this with K plus 1s in it. All right, but I understand some of you aren't going to be able to do that, and that's okay. You don't have to do that. We know that that would be too much to try to squeeze into one chapter. All right, so that's what we need to know about the induction. So then the next thing is, going backwards in time, we did binomial theorem. And so let's just do a simple expansion. Say I had 2y minus 1 to the 5th. I'd like you to stretch that out into, it's not 5 terms. How many terms are there? 6. And I made a mistake last hour in doing my really complicated one with binomial, because I forgot that if there's 5 terms here, then there's better be 5 for n, I guess you'd call it. That there better be 6 terms for that. And there's a pattern. Okay, write this one out. You start with the 2y. Right. Start with the 2y to the 5th. Your first term has a 2y to the 5th in it. And then it goes down from there to 2y in parentheses to the 4th. me pause while you give this one a shot. Okay, by now you've probably had plenty of time to finish these up, and I hope you knew this is a little pattern going down 2y to the third, 2y to the second, 2y to the first. And this is why we don't just have the same number as this. You know, if there were 5 terms only, we would stop right there. But there's also a 2y to the 0. And that one should actually be out there, but it won't really matter. And then the other one, it walks slowly upwards. So the negative one, I hope you used the negative one. Raise your hand if you used the negative one. Good. Walks up from 0 to -1 to the first, -1 to the second, etc., etc. And then the last piece is the number in front. You can get it from Pascal's triangle. Saw some people drawing out Pascal's triangle. How many of you did it with Pascal's triangle? All right. So if you didn't do it with Pascal's triangle, you know something precious. Pascal's triangle people, you will have trouble if that's all you can do, because they're going to ask you for a number of terms that is like something you're not going to want to draw a triangle for. Okay? This one wasn't that bad because you had to find the 6th row of Pascal's triangle to do this. But if I needed this spot right here, which is the first term, second term, third term, fourth term, do you get that's the binomial theorem? The binomial theorem has this little thing in it called n over j. Okay, and that would tell us that coefficient, not having to ever write out Pascal's triangle. So everybody please tell me, what do you think over what do you think for the 4th term? What would, I know you know Pascal's, many of you, but figure it out with an what number over what number? And this will be a factorials little problem. Let everybody try to do it with themselves first. For the 4th term, it would be, raise your hand if you think you got it. Okay, if you don't know, pay attention then. What do you think? 5, it's always 5. That's always 5. No matter which of these you're doing, which of the lead coefficients you're trying to find, it's always 5, 5, 5. Okay, now what? You are correct. It's 1 less than whatever term it's on. So this one's 5, choose 3. Make sense? 5 choose 3 is found by 5 factorial over 3 factorial with an extra, a little more complicated one, which is what? 5 minus 3, which in this case is 2 factorial. And that's like 5, 4, 3, 2, 1 over 3, 2, 1, and a 2, 1. And the 3, 2, 1 cancels 3, 2, 1, so it's 20 divided by 2, which is 10. And I know some of you that are like, well, Pascal's would have been so much easier. Just write out the whole Pascal's triangle, and you'd have known it was a 10. But when I change the term number to really big, I hope you can do this. Yes? Okay. All I can tell you, if you look at the binomial theorem, they start counting at 0 in the binomial theorem. On the bottom of the little sigma thing, it says 0. So that kind of throws off, and it's not, you know, when the very first term, do you get how the very first term, it couldn't be a 1 on the bottom? Because you start with 0. Because it's n over j right here. These numbers are n and j. And in the binomial, n is this. That's just n. So whatever the power is, goes right there. Like I said, that's always going to be that number for every single one of those little choose brackets. But this is j, and on the very first term, it's 0. So that means the second term, so this one will be 0. This would be 1, 2, 3. And a way you can get it is it's always 1 less than whatever the term was. If it's the 4th term, then you put a 3 there. Okay. Given what you know about this, oh, by the way, let's fill these in. From Pascal's triangle, I know this starts with a 1 and that ends with a 1, right? And what was it? 1, what? 1, 5, 10, 10, 5, 1. Cool. All right, so let's just finish off like this one. If this has a 10 in front of it, it's 10 and then 2 to the third and then -1 squared and then a y to the third. And what is that term? Everybody, figure this one out. If you didn't get it before, figure it out now. What's the third term? Notice how I can make the problem easier by just asking you for the third term? And that's what they do on the really, really big ones. Because if I asked you to expand out x plus y to the 31st power, it would take you a long time. But if I said, what's the fifth term, that wouldn't take that long. Yes? Tell me. Not just the answer, but how did you get it? Okay, and that 2 to the third part becomes, and then you times that by the 10 gives you 80. 80 what? Y to the third. That's it. Negative 1 squared just makes 1. Exactly. All right. So let's see if you could do this. Let's say it is 2x minus y to the 17th power. I want to know, what would the 16th term be? Now be careful on this. The 16th term is not the second to last one. How many terms are there? There's 18 terms. Remember that. That makes a big difference in how you do it. If there's 18 terms, I want the 16th term. All I'm saying is, here's the last term. What's the last term? The 18th term. What's the second to last term? 17th. What's the term before that? 16th. So I would call that not the second to last term. I guess you'd call it the third to last term. I don't know, but it's not the second to last. Yeah, I know. I get what you're saying, but you can't. If this is second to last, what is this? First to last? I've never even heard of that. Okay. So I'm asking you for the 16th term. Again, Pascal's will fail you. So, I guess you could. You're right. But don't, because the test might be 117th power, you know? Yes, exactly. At some point, it would become impossible to do in the time allowed. All right. It has a little choose thingy in front of it. Miss J, can you do the little choose thing? 17 choose 15. How'd you know that was a 15 so quick? Yeah, you just take the 16th term, but with one less than that, so it's 15th. There you go. 17 choose 15. That's the part that the people that were locked into Pascal's triangle need to understand. That will give you the Pascal's triangle number. 17 choose 15. Which breaks down into 17 factorial over 15 factorial with an extra 17 minus 15, which is 2 factorial. It is. You can leave it as a big multiplication problem because, actually, you know what? You're allowed calculators tomorrow. Why don't you take out a calculator right now and get this thing exact? Get used to having the calculator available. Miss C, tell me a little more about this, like maybe one of those other terms. Yeah, like what, how do you get them? How do you find the answer here? Yep. 2x to the 16th. Now, how did you know it's 16? Like versus 15 versus 17 versus 18? So you're using the binomial where it says a to the n minus j and J is not which term we're on. So let me think. So I think you're off one. Here's the way I would do it, and you tell me if this makes sense to you. Would you agree that on the last one, the 2x it's shrinking each, hold on, wait till I'm done. Would you agree that the 2x has been started with like a 2x to the 17th? And then I keep going and going, and how does it end with 2x to the, okay, there we go. So you just said it, 2x to the 0 is how it would end, and therefore this must be 2x to the 1, and this would be 2x to the 2. Could I have gotten it with the binomial? Yeah. But I got to remember that I do n minus j for that part. And my n was 17, and my j was that this was, I really wish they had the binomial cleaner, so it was like 17 minus the 16. It's because it's the 16th term. But it's not. It's 17 minus 1 less than the term you're on. All right. So I would have reasoned this one out to get that 2x squared. How about the other one? We want to try to explain the other one? Yes? It's a negative y, and you're going to do what to it? Now, how did you know this was negative y to the 16th? All right, and that again, trying to follow the binomial, everybody thinks that j is what term we're on. J is not what term we're on. It's always 1 less than that. Okay, so it's not 16. It's almost like figure out what you think it should be and then subtract 1 from it. Now think of it this way. Remember what I did last time when somebody got stuck? I said, think about the end. How would this end? What's the end game? Negative y to the what? To the 17th here. So then back here it would have been negative y to the 16th, which makes this one negative y to the 15th. All right, and this little calculation came out to 17 times 16 times 15, blah, 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 over 15, blah, 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 times 2 times 1. The 15's down would cancel, so it's 17 times 16 divided by 2. This part right here is 17 times 16 divided by 2. Then we times that by 2 squared because of this. And that would be our coefficient on it. Some big number, x squared. And negative y to the 15th, does that negative stay there then? Ah, so our coefficient's negative big number. It's y to the 15th. I don't know what the big number is. If somebody can tell me what 17 times 16 divided by 2 is, I guess I could simplify that a little bit. 16 is 2 times 8, and then I can cancel the 2's. So it's really 17 times 8, whatever that is. After you multiply by 4, it comes out to 544. All right, thank you. There you go. I know, a little intense. But hey, you're an honest pre-calc. It's supposed to be hard. All right. Do you want to do another one like that or not? I need to get a thumbs up or thumbs down. Everybody, give me a thumbs up or thumbs down. I want another one. I don't want another one. All right. Thumbs up means I want another one. All right. They're mostly thumbs down. So if I have time at the end, I'll do another one for you. All right. So I am going to move on to a different topic. And these should be your easy points, your happy place. All right. Say you had a series that started with a 7. And then there was a whole bunch of other terms. And then eventually there was a 512. Let's say that it was geometric. Then, this is the first term. Second, third, fourth, this is the 5th term. And what I want to know is, what is the common ratio and what is the sigma notation for this? Write it in sigma. You need a number here and here, and you need some stuff here. Okay, you can get help from those formulas they showed you at the beginning of the hour. One of them definitely applies. Remember, I said this was geometric. Calculators are allowed on this test. They are not allowed, however, on the final. Pause for a second while you work on this. Okay, some thoughts on this. I'm hoping you're not using guess and check, because that will not work if you have a whole bunch of terms. It could work in a small problem like this, but so do you know, since we're doing geometric, that we got to use one of those formulas over there? Did I give you the sum of all the numbers? I did not give you the sum of all the numbers, therefore that formula is out. So this formula is the only one left, unless this is an infinite series. Did I imply it goes on forever? No, therefore there's only one formula that could work. A sub n equals a r to the n minus 1. What is a sub n? It's any term, except I know that I have the fifth term, and it's 512. Do you get why I can put 512 there? And then the a is the starting term, so do you get why I can put a 7 there? And since I know I'm dealing with n is 5 because I've got my fifth term on the board, this must be a 5. And therefore, it's 512 equals 7 times r to the 5 minus 1, which is to the fourth. And then I would get the clump alone, and this is the clump, so I'm going to divide by 7. So whatever 512 divided by 7 now has to be put to the 1/4 power to finish it off. Could you help me tell what that is? 512 divided by 7 to the 1/4 power? Somebody else must have done this. 2 point what? 2.92? Can you guys agree on that? Okay. I'm going to even make it simpler. 2.9. Let's say it's 2.9. Okay. So if R is 2.9, then you should be able to use that same formula right here. Summation from 1 to, how many terms were there? 5. From 1 to 5. Of a times r to the n minus 1. What's the a in this case? 7 times r. What's the r in this case? 2.9 to the n minus 1. And you have to leave that in there because this is really n equals 1. And there we have it. That's the term generator. Now that we're this far, may as well finish it. Use the sum formula to figure out the sum. Okay, so the sum formula for this guy, this is a geometric, so I go to D. Formula D that we referenced earlier is S sub n, sum of a limited number of terms, is a times 1 minus r to the n over 1 minus r, except I know some of those things. The a is the first term is 7, so I put a 7 there. And the r is 2.9, so I can slap that in here and here. And I even know n. What's n? 5. So I can put that there. Raise your hand if you were on the right track for that. Were you on the right track for that? I actually need the response from that. Raise your hand if you were on the right track for that. Okay, good. So then I don't have to worry about, like, keep going with this. All right. why we set that up. So now it's actually just grind out the numbers. Someone who's got an answer. That's a decimal. Come on, only 2 people know how to put that in the calculator? Well, shouldn't it be well, does it come out perfect? Okay. What did you get? 770 point what? All right, and again, that's subject to rounding error, but can anybody else verify that number? Quite a few people. Okay, good. Okay, cool. You understand how you're going to use formulas a lot. I used formulas twice in this problem. You got to be able to use those formulas. You don't have to have them memorized. We're giving you the sheet, but you got to be able to use the formulas. All right. Well, let's say I have something that starts with 10, and it's arithmetic, and it's got a whole bunch of terms. We'll be specific. It's got 6 terms. And it adds up to 600. Then tell me, what was the second term? It's arithmetic. It's got 6 terms total. If the sum is 600, hint, you have to use formulas. Don't try to do these guess and check. Tragic. I'm not using nice numbers on purpose because I want you to see the formulas are what you need. I mean, 10 and 600 are nice numbers, but common ratios, or sorry, your common difference is probably pretty ugly. Okay, let's see what random person has to say. Row 1, person 5. That would be the guy in the gray sweatshirt back there. How do we start this thing? Please tell me a formula. You started with a formula, right? Okay. If you do this formula, I want to warn you, I know A, I know N, but I don't know, I'm not going to know the D. I'm not going to be able to find the D from this. I don't think that formula would work for you. Okay, so let's use the other one. Go ahead. What is it? All right. Now, I still don't know the difference, but at least I know one more thing on this formula. I know the sum. So that's the right formula. How many of you guys used this formula? Okay, good. Did you stick in 600 right here? Good. Do we know N as in the number of terms? Yeah, it's 6. So I can put a 6 right there. And then do we know A? Yes, it was 10. So that's 10. And then did we know the number of terms again? Yes, that was 6. And then basically I can solve for D. Once I know the common difference, then I know what's added each time. So 600 equals 6 divided by 2 is 3, times 2a is 20, plus 6 minus 1 is 5d. Wow, they cleaned up really nice. So then it's 600 equals 3 times 20 is 60, plus 3 times 5 is 15d. And then I'm going to subtract 60, then I'm going down to 540 equals 15d. So divided by 15, and I have my d. So now that factor, whatever that decimal is the thing. Is it 36? Oh my gosh, weird. I made it work just totally off the top of my head. Sometimes I wonder if your subconscious can like solve things incredibly fast and create them and make them work. All right, so, or there's just luck. D is 36. If D is 36, what was the second term? 46, because you add it each time. No, hold on. You just said that if the answer is that obvious. Oh, if you got all the way down to showing me that work up to 36, I'm fine with you saying the answer is 46. But you would have to show me all of that work, yes. I would not say you could do this one in your head. And I almost never do that. So, all right. So that's enough review for your test for tomorrow. If I were you, I would go back, look at some past problems. Any place where you had weaknesses, I might do the problems that we had skipped, look at the old keys, and that's all I have for you for today.